thanks everyone for joining firstly. Today we're going to talk about our Xsite product range and in particular the Infield design feature with the Xsite Pro. We'll take a brief look at some other products that we also sell for the civil construction market and maybe just a brief history on who we are, as there's a fair few new customers who are looking at purchasing systems and not so familiar with our company and our background story. So I think we'll go through that now. So today I'll start the meeting and I'm joined with my colleagues, so Jörg from our 3D product line manager and Sam from our support team, and they'll both be co-sharing. So as I mentioned, introduction into MOBA, Xsite product overview in general, some product news, some updates on some of the hardware products, and then we'll jump into this Infield design feature, and then some Q&A session at the end. Some housekeeping. So you can use the chat box to raise a question. If the question comes to you afterwards, you can certainly reach out to us via our support email, which is on the screen, and then we can go from there. So brief history into who we are. So in 1980, we started under Monochromatic Engineering, MC Lasers, based here in Melbourne, specialising in everything to do with mainly land levelling and civil construction. In 2004, we became a MOBA dealer and started selling MOBA products. So we were an authorised dealer. And then in 2018, we were purchased outright from MOBA. So now we're a full subsidiary of MOBA AG, and we sell the full range of Xsite products, civil construction products, paving products, and also specialty products. And then in 2025, we expanded our footprint along the East Coast with some more representation. And so now we've got staff in both New South Wales and Queensland. So system portfolio. So I mentioned already earth moving, which is the Xsite product, which many of our customers know and love today. We've also got road construction, where we're heavily involved. Waste products, which is a very special market segment that we do. So equipping a variety of weighing cells to pickup trucks, and also the same for cranes and lifters. A bit about our team. So we've got a dedicated team of not only engineers, but technical staff, sales, business admin, and team that manufactures some products here. We not only distribute MOBA products, we also do a lot of in-field or in-house manufacturing right here in Melbourne. Those products are sold both locally here in Australia, but also across APAC and Europe. So we certainly export a lot of our products. A lot of that work is in-house R&D, design the products right down to the software level, and then manufacturing them. And now I think we'll hand the reins over to Jörg and Sam, and they will deep dive into the machine control product portfolio.
Yeah, thank you, Daniel, for the introduction. Also, welcome from our side, from myself, Jörg, and from Sam, of course. So before we dive into the Infield designs, we thought it's a good opportunity to show you the complete product range again in the Xsite world of MOBA. So everything that comes to earth moving, especially in excavators. We have our Xsite Easy product. That's our 2D system for excavators. 2D means you can bench to a target level, or you can use your rotation laser to get heights. So whenever you don't need 3D workflows, Xsite Easy might be a really interesting product for you. Additionally, we support all types of excavators. So no matter if you have a tilt attachment, tilt rotator, tilt bucket, whatever it is, we support it with the Xsite Easy. And of course, if you have dual booms or swing boom on your machine, that's also fully supported in Xsite Easy, up to dual slopes where we use a compass. So we strongly believe that upgrade paths are important. So even if you start on an Xsite Easy product, all the hardware can be used and updated to go to an Xsite Pro system. You can see that here on the right-hand side. It's a hybrid solution. It's a 2D and, of course, a 3D system for excavators. Suitable for all sizes of construction site, from small infield designs, which we're going to take a look today, to loading massive designs, which we covered at the last webinar. You can find all recordings on our YouTube channel, of course. And of course, also with the Xsite Pro system, we support all kinds of attachments, all sizes, all types of excavators. Then apart from the excavators, we do offer indicate solutions. Those can be for skid steer or wheel loader, or they can, of course, also be for a dozer or whatever other attachment you might have. Apart from the visual or guidance only systems, we also offer the Xsite Pro dozer system. So same hardware platform, same software platform as the excavator. And of course, here we can also automate the blade of the dozer in height and in tilt. And we support most brands and types of dozers. All the software, all the hardware is the same. So whatever you see today in the Infield design webinar, you can do on all the machines that you see in these slides here. Then a little bit more, not so much on the earth moving, but still it's an Xsite product, a drilling product. That's our drilling navigation system. So you can see it here highlighted. We got these drill hole patterns that we want to build. Those can be imported or self-created as well. For drilling machines, that can be cabinless drilling machines, that can be drilling machines with cabin, or it can be drill attachments for excavators. So Xsite Drilling is also available from us. And then if we look a little bit further to the infrastructure on the job site, we have our GeoMix surveying solutions. So any needs that you might have on GPS rover side, on GPS base stations, but also, of course, on total stations, could be robotic or manual total stations. We teamed up with GeoMix that offer a really nice software solution on a very good Android tablet, allowing you to really have easy workflows and still have surveying great accuracy. So these are the Xsite ecosystems. Of course, every now and then there's new things that we would like to share with the group, and we're going to take a look at that. Latest and greatest, what we have here on the machine control side available for you is our new Xsite Pro 10-inch display. The previous one you saw on the slides, in the product presentation slides, was an 8.4-inch display that some might be familiar with. So the 10-inch offers, of course, a bigger screen area, so 33% brighter, in addition to a 20% larger screen area. And that also quite relevant for the excavate application, improved viewing angles. So you can look at the display not only straight on, but also in quite big angles from the side. And you still see all the colors, all the details you want to see from your job site crystal clear. We also improved the touch panel on the display. You will see it's slightly more active, but the biggest improvement, anti-glare and anti-fingerprint. So even in direct sunlight, you will see the display content without any issues. Anti-fingerprint, that's always good. And of course, you can use the systems even when very close. Compact design, why the screen got bigger. That's what you can see here on the right-hand side of the screen. We use the screen bezel. That means the footprint of the display is actually smaller than the successor, the pre-successor, the 8.4-inch version, but the screen area is larger. So it's a nice thing to have. It won't take more space in your cabin, which is quite crucial for depending on the size of the machine. It's also compatible to existing installation. That means the connector is the same, the RAM arms are the same. If you want to go for an upgrade, a small software upgrade is required then on the software side. But hardware-wise, no modifications are required. Then the other news, some of you might have seen it already, is our latest generation of IMU sensors. So these are the sensors we put on all movable elements of the machine, in case of an excavator on the frame, on the boom, on the stick, on the bucket, and of course on the tilt bucket if you got one. And before that it was our G2 sensors. Now it's our G3 sensors. They come now as a standard with all systems shipped from us to you. They offer improvements in accuracy and speed compared to the G2 version. A new design, so it's still a fully sealed aluminium housing, so still you can do all your dredging applications. You don't need to worry about anything regarding that. And we also have a new surface coating. That means it's even more robust to abrasion. Same footprint, that means same layout, same installation methods, everything stayed the same. On the right-hand side, we try to visualize a little bit what that all means in the real world, the updated G3 sensor. So what you see in the blue chart is faster settling. That means when you stop, especially the movement of the bucket, you will see a clear improvement how fast the bucket stops on your screen. So imagine you stop the bucket movement in reality, and the time till it also stops moving on your screen is really reduced now. That being said, already the G2 sensor was really incredibly fast. But you will see the difference if it's next to each other. Reduced oscillation, that means less wobbling in the height. Yeah, if you have the back and forth rocking movement, especially on the frame, you will see that going down significant with the G3 sensor. And lower noise, that means you can really smooth and accurate, perform cutting really smooth and accurate. All of that being said, the G2 sensor offers you already a lot. So if you have existing machines, we know a lot of machines are out there that are not fully calibrated to the fullest potential of the G2 sensor. So if you have the feeling that the system is a tiny bit slow to you, please feel free to reach out to us, and we can take a look if the G2 sensors that you already have can be optimized, or of course, we can discuss what an update to our G3 sensor could look like. Good. I think these are the product news we wanted to cover in today's meeting. And then we're going to dive now into the big topic of today, Xsite Infield designs. Last time we looked how to use our Xsite Managed Cloud solution to get pre-created designs into the machine control system. This time the scenario is a little bit different. You arrive to a job site, but you don't have any designs, at least no digital designs that you can just load. So you need to create them yourself, directly on the machine in the field. Xsite allows two basic workflows how to do that. We can talk about 2D designs, and we can talk about 3D designs. So to give you a bit of an idea what we mean when we say a 2D design, a 2D infield design, the screenshots on the right are from our Xsite Easy product. And the first workflow is fairly simple. You have a datum point that you can see here on the right-hand side where you can touch your bucket onto. And we know from this datum point we need to cut 2.5 meters down. So all we need to do is put our bucket on the datum point, dial in a height offset of -2.5 meters, and then we press the 0 button to confirm that our bucket is on the datum point, and then we can start cutting. With that methodology, we can create two different designs. That would be a flat pad, like shown on the picture, but we can also add a single slope to it. And of course, we can use that with an Xsite Easy or an Xsite Pro system. So both systems on the excavator support that workflow. Important to know whenever it comes to 2D workflows, the moment you move your excavator, you will need to bench again to your height reference. In our example, that could be either the bench point that you touch initially, or it could be benching to the already excavated surface. Similar story, that's the second 2D workflow, and then we're going to transition over to the 3D workflows. If you have a rotation laser and a laser receiver on your excavator, you can utilize that. Basic idea, here on the first picture on the right-hand side, you got your laser set up, your rotation laser set up, and you dial in the height offset from your laser to your target height. There are different ways how to dial that into the system. We don't want to go into too much details today into how to set it up in the best way, but at the end it all does the same. So we dial in an offset from our laser to our target height. In this case, it's negative 2.5 meters. And we can also define a slope with it. If you have a laser that supports dual slopes and you have the right sensor set on your excavator, you can also dial in a second slope, so a long slope and a cross slope. And that would also work with an Xsite Easy system or an Xsite Pro system. Important to mention also with a laser as a height reference, every time you move the excavator, you drive it with the drags, you will need to swing again into the laser beam. And the reason for that is rather simple. The system has no idea if you did drive uphill or downhill. So, but today we want to focus especially on 3D infield designs. The biggest difference between a 3D and a 2D infield design is that in 3D, we're going to use our GPS, or better GNS receiver that is mounted already on our excavator. And the difference to a 2D workflow is we know exactly the height of our bucket from our GNSS signal. But in addition to that, we also know the position where we are on the job site from our GNSS. And that's especially interesting when we go towards the end to the complex profiles, because here it's relevant for us to know where we are located in the profile, because we have multiple slope changes in our profiles. So for the 3D designs, we do require the Xsite Pro and of course the matching GNSS hardware on our system. So I'm gonna run you through the first set of examples and then I will hand over to Sam. We quickly gonna adjust our screen just to bring up our simulator. So bear with us just a second. So we're just gonna start up our simulator and then we will go from there. I take a moment or two for the simulator to fire up over here. We can take a look at the first example that we want to show to you. I hope everybody can still see our screen and you can see here the simulator loading up on the right-hand side. So on our first example, we want to build a house foundation. And the information we got provided is the RL level, so the target height of our house foundation. Yeah, in this example, it could be 125.30 meters. Additionally, we want to build a garage foundation at the same time. Yeah, and that has a slightly different RL level. So you can see here the simulator on the left-hand side. That is exactly the same like you would see on your excavator. So we start from scratch. So we go into our right-hand menu. In project, we're gonna create a new project. We can name it so this is our first example. And in here already the system will ask us, hey, are you using a 2D project or you want to create a 3D project? In our case, we said we're gonna create a 3D project. Coordinate systems and intuits, if you're interested, give us a call. We can guide you through there. What's the meaning of that? We're just gonna leave it now as it is. And what happens now, we created our flat pad design. You can see a small symbol in front of it saying 3D. So we know that's our 3D job site. As you can see, there are no models inside. So if we go back to the main user interface, this is just our excavator that looks like a little bit lonely here. Nothing to cut to. So we want to create now our house foundation. So how to do that? Under the project, we got our file management, where we have our models. We click on add, and we know we want to create a flat surface, a plane surface. So it will ask us for a name. Often we leave it as it is, then it's just the timestamp. Yeah, that's our Melbourne time zone over here. In this case, just to keep it a little bit easier for us, we're going to call it house. In the next window, we can dial in directly our known height because this is what we've been provided with. And in known height, we can just dial in our height. of 125.30. Of course, we can also dial in 301 if it's relevant to us. Okay, all we need to do is confirm. And what happened now? We created a new plane. Doesn't look like I clicked on house. Oh, it just updated. So what happened now? Here we got a blue square that's rather big, kilometer by kilometer. And we got our excavator right in the center of the square. And this is already our house foundation. What you see here in the lower part are cross and long cuts through the design. There's not much going on. This is just a flat profile. Relevant for us on the operational side is then the value 0.03. That means we are 330 mil below the target design. If we go up a little bit, you will see that now we are pretty spot on the level we want to cut. So that was first half of the job we needed to do. So we created our house profile, but we also know that at the same time, we want to build up our garage. So we can create exactly the same. We're going to create another plane. So if there's any typos, just ignore them. So we can dial in our target RLs. So this is our second one. And we have now created our garage. But it looks like I might have made a mistake, because if I look into my models, it says here known height 124.60, but I was supposed to dial in 124.50. So what I can do is I can either delete it and create a new one, but I don't want to do that. So I can just dial in my correct one if I adjust the known height from here. So what happened now? Exactly what's supposed to happen. We changed it to the correct RL level. So on the left-hand side of the screen, we got this file up and down arrows. And with these ones, I can toggle between the two designs, which is great if you know this is my house. You got a layout of the house. I know I want to go to the house or to the garage. What is also kind of useful is this status bar down here. You can see it's toggling through all the information. And that's maybe a not well-known function of our system. If we click into it, we can enable or disable the visibility. So in our example, we can just say we're only interested to see the current file name. That's down here. And then we have a direct indication of which design we're cutting to. And of course, we also see two different colors. So we know gray is the garage, blue is the house, and then we can start cutting away. Cool. So I think that is everything I wanted to show you on the first example. Of course, all the basic functions are there. So on the top hand left side, you can select the focus point of the bucket. That is always the same with the Xsite solution. Good. That was the first easy example. Then we move on. We want to create a single sloped surface. As you can see here on the right-hand side, we get the following information. We know that we should create a 3% slope. The slope direction is defined by 0.1 and by 0.2. These could be pegs or any markers there. We know that the length should be 15 meters and our width of the design should be 5 meters. 0.1 is marked by a peg, and we know that our target height is 300 millimeters down from the peg. So we're going to build that by starting from scratch. So we create a new job site. So I call it A because we have two different ones we want to show to you. How to do that? We can make our life a little bit easier, but the basic idea is we're going to use a function called advanced profile. And we're going to do it so that we're going to store our first point. We're going to use our bucket of our excavator. We're going to put the bucket on the first point. We're going to store that point. We're going to drive to the second point, and we're also going to store that point. And then we're gonna build a line between those 2 points that defines our slope direction. We're gonna add a slope to this line, and we're gonna build additionally at the end a profile based on that line with the correct slope, with the right position. So we now drive to our first point and we click on store point. So we can see now here on our screen the first point showing up. It's called point 1 point. Since we want to make our life a little bit easier, we're also going to activate our quick buttons that can be found from the left-hand view. If you don't have that active on your excavator, you can activate these quick buttons and you can configure most functions that you find in the system directly on the quick button. So a common setup could be something like that. So what that allows us to do, we got our first point. Like in the picture, we're going to drive to our second point. And then we can, instead of going to the left-hand menu and then selecting store point, we can just shoot a point directly from the user interface. So we recorded our 2 points. Then the next item we need to do is we need to build a line. But before doing so, we actually forgot to do one important thing. We didn't adjust the 300 millimeters down from our first point. So how to do that? We're going to drive back to our first point. And we want to show you that because that's a quite common question. There are multiple ways to do it. So that's the first one. We're going to apply an offset. And we're going to measure that point. And in here, that allows us directly to enter an offset. By default, it's 0. In here, I'm going to dial in 0.3 meters, so 300 mil. And this will shift the point 1 directly down 300 mil. So this is our point 3 in this example, because I messed it up. So we're going to store a second point. So ignore the 2 points here on the left, please. We're going to store a second point. In here, it doesn't really matter. We can use an offset or not, because we're going to define the slope from point 1 onwards anyways ourselves. So these are our new 2 points. And along these points, I'm going to build a line. So how to do that? Back into our model tool, add line. In here, it will ask us to select the points we want to use. So I will select my first point. I will select the second point of the line. And I'm going to click here on slope. So what does it do in slope? We can adjust our slope to match our target slope. In our case, it's 3%. Actually, it's in decrease. So that's interesting. So we can hold our finger down and we can dial in here percent. 3%. Easy, if it's positive, it rises up. If it's negative, it goes down. What we also can do is we can extend the profile. As you can see, the point 2 is not in the corner, but it might be somewhere in the middle of the field. Point 2 only gives us the direction for the slope. So all we need to do here is enter 15 meters, as we know that the length of our project should be 15 meters. Cool. In here, we can change the direction. That's not too relevant in most cases. It defines the starting point of the line if you're interested in your chainage along the line, so distance you travel along the line. So what we created now is our line. And we could already use that line if we go to our line measurement dashboard. The top value gives us the height, the cut fill levels to the line. But since we want to have it a little bit nicer and also get some visual indication how wide our object should be, our design should be, we're gonna add an advanced profile to our line. So we're gonna call it something that's easy to remember. We're gonna build a single slope, and you will see it in a second what happens. We know that our width is 5 meters. And it's actually easy if I will show you the result. So what happens now is we got our line, and to this line we attach this 5 meter wide profile. Of course, we need to select to which side we want to build a profile, so left or right. In this case, it would be the right side. Good. And what you can see here, this is pretty much what we built. A sloped surface, a 3% fall or raise, depends which direction we're facing. 5 meters length, 15 meters length, 5 meters wide. No? So, in our second example, I'm going to keep it short looking at the time. The only difference is that we actually have the target RL value of our first point. So how to do that? We're going to quickly create a job site. I'm not going to make that nice anymore because we're experts by now. So same story. I will shoot a first point. Now I want to show you a different way how to do it. So this is our first point. And we know that our target RL is 1.45. That's not going to match the first point because we can't reach the finished surface level. It's clear. You can only survey what's currently there. So one way to do is we're going to go to our job site and we can edit our point. So it might have been a little bit too fast. So in our models, we have our log file. In our log file, all the points that we stored with our systems are saved. And we can edit those. So we can click on the small edit icon here. We can go to as-built data and we select the first point. And you can see that in here, we can just dial in our correct RL level. So this allows us to manually move the first point to the correct RL level. And now it's pretty much the same. We're going to measure up our second point. Same story as before, so I'm doing it a little bit fast. We're going to build our line. We're going to build our line starting from the first point to our second point. Here in the I button, you can see our L level of 0.1 is exactly how we want it to be. And we're going to adjust our slope. So that's something we should adjust together in a second to be in percent always. We're going to have it at 3%. We're going to have it 15 meters. And then it's just doing exactly the same as before. We're going to add our advanced profile. We're going to add one slope element or one element to it. We're going to have it at 5 meters. We're going to attach it to the line we created. And we're going to put it to the right location. And that's how you could create quickly based on the information provided. So the RL level of 0.1, the slope, and the basic geometry of the single surface, your design. Cool. Then moving on to our next mission. Now we created a single slope surface. We want to build now a dual sloped surface. And we are almost there because the basic idea is pretty much the same. So you can use the same ideas that we just introduced about how to adjust the starting level for the first point, exactly the same. So in our example, we're going to do the method of adjusting an offset value. So we're going to put our bucket on the peg. We know 300 mil below the peg is our target RL level. We're going to measure that. We're going to dial in our 300 millimeter offset. We're going to store the point. That's our first point. We're going to drive to our second point. We're going to store our second point. Again, here it doesn't matter if there's an offset or not. Let's click on it twice. Yes, beautiful. So we got our 2 points. We're going to build our line in this case. So we also see we can dial in different values. We're going to put in a 1% fall or raise over 20 meter. So we're going to click on our first point that we already shifted 300 millimeters below the peg. Let's select our slope. We know in this case we want to have 20 meters. And we know that we want to have a percent of 1%. This is going to give us our fall between 1 and 2, 4%. Good. So far we are familiar with that one already. So we have our 15-meter, 20-meter long line in this case. So the next thing we need to take care of, building a second element that's 15-meter wide at 2% slope. Add advanced profile. As we've seen that in the earlier examples already. One slope element. And now we're going to do it 15 meters. We can lock that so it can never be changed. And we can dial in then our 2% slope. Right? And you can already see the slope direction. If that's not correct, you can adjust to the -2, then it falls, or +2. So you get a direct visual feedback. So the only thing we need to define where we want to anchor the profile to. We're going to say we surveyed now here the left corner of this profile, and we're going to select the line that we created earlier. Now this is our line that we just created. And in the last step, we just need to say, okay, I actually want it to run to the right side of the excavator. Good. So what we got now here is our slope surface. And you can see now something happens on the long and cross cuts. You can see in green direction, it's all the ways in boom line. That's our long cut, 90 degrees to that. It's our cross cut, our red line, and it's green. What can be useful, especially if you're building slopes, dual slopes, any type of slopes, and you want to get the most out of your tilt bucket, we can actually go to our profile view gear wrench and activate our bucket arrow indicators. And you will see in a moment what that gives you. Now you got in the middle of the screen an additional line that gives you the cut filler level on the left edge of your bucket. So it's -0.01 on the right hand, -0.05, and in the middle, a tilt angle difference. And this is your current tilt angle of your tilt bucket, tilt attachment, whatever you got, compared to the target design. So that means if it's close to 0, your bucket and the target grade matches. You can see right now we have 1.2 degrees off. That means you would need to tilt your bucket 1.2 degrees. In this example, the left side would need to come down to match the target grade of your design. That's always possible to activate, no matter what kind of design you have, if it's self-imported or self-created. And you can see these values then change accordingly. Good. And as mentioned, you can also dial in the target RL of 0.1. There's no difference there. So these were the slope examples, the flat pad designs. And then we're going to continue with more complex designs, and I will let Sam run you through that.
Okay. Thanks, Jörg. So we'll start off with a drainage profile here. You can see the nice image on the right side and underneath there. Sorry, fat finger. So we're going to start by building a swale drain or any type of V drain that's similar design to this green profile with a batter, a floor going to a batter. So we want to build this a complex profile, again, using our advanced profile in the Xsite system. And these profiles follow a line. Typically for the drainage, it would be the center line we marked out, but the toe of the batter can also be used, or the top of the batter. So in the example here, we're going to build a, here we go. We're going to be building a drain with 3 to 1 or 1 to 3 batters. So I'm going to make a new project here. Make sure 3D is on. So in this example, we're just going to store some points, as already mentioned previously with Jörg. Store some points. And the thing to note on this example, we're going to do 600 mil below our starting point. So an example for this might be You can't touch the bottom of your pipe for a culvert or something similar, where you've got a 600 mil diameter pipe, but you can only touch the top of it, and we would like to offset it down 600. So the previous methods shown where you can offset the point directly if you're confident, or edit the as-built data of the point, and this is just a third example of how to modify the designs to match your needs. Just going to make sure the offsets, we'll turn that off. Okay, store our point, and we'll store a few more points here. Okay. Yep, good. So now we're going to do the same. We're going to build our line. Models, add line. Okay. I'm going to choose our starting point. Point 1. Continue on with point 2, point 3, point 4. Okay. In the example, we can see the long slope is 0.5%. So we can click on slope. Again, adjust it to percent instead of degrees, which we'll cover in the next step, how to adjust the units, default units you would like to use. So 0.5%. Okay, you can go 2 decimal places here with the slope. And the length, we had the start and end point, so the length we're happy with. Okay, there's our line with the kink. Change direction again for the chainage measurements. So here's our line, here's our base. And now we're going to add the advanced profile to this line. Okay, add advanced profile. And you can give it a name to make it easier. So number of slopes. So what we're going to do is we're going to add 2 slopes, 2 profiles. All right. And we're going to use the duplicate slopes button. So it's a symmetric design and it saves inputs, which makes it a bit easier to build your design. So 2 plus 2. A bit fast. So this is our first profile, which is just going to be the batter 1 to 3. Okay. So we know the ratio. Okay, so hold our fingers down on the slope. We want ratios. Okay, minus 1 to 3. You can see it here in the design, 3 across, 1 down, very lit up with the purple or the pink and green. We know that slope, so we lock it. Okay. And for the width, we're going to say it's 3 meters. Okay, we go to the next profile, next section. Now this is the floor, and because we are duplicating it across the center of the drain, we want to make sure that this is half the floor width. So in an example, it's a 3 meter wide floor, therefore 1.5 meters because it's going to get doubled to the other side. Okay, reference line up the top, where are we going to attach the profile to the line? You can see the red orb in the center of the floor here. That's where our line is. That's the center line, and that's where we want to attach our profile. Now we choose our line, hold your finger on the screen, select the line. There's a quick view of our profile. And again, in this screen, because it's symmetric, the swap quest section will do nothing. The profile. So yes, if we zoom in and drive a little bit, we can see now in our cross-cut, long-cut, cross-view, long-view profiles here, the profile view, you can see that the batter's either side in the red, and again, the long slope running with the green. So this could be an example that we're on top of a pipe, or also reclaiming the ground. So to say, we want to dig out 600 millimeters and then put 600 millimeters back. And an easy way to do that is with the project offset feature. So the bottom right menu and then project offset. Okay, here, positive is up, negative is down. So minus 0.6 is our 600 millimeter offset. So now you can see in the profile view, a gray line with the green and red line, and the gray line would be original surface before the offset. But now you can see our cut fill values have changed, 550 mil now. as we are digging deeper with this 600 mil offset, which is shown on the left side of the screen here. To reset that, go back into project offset, type in 0 or press the reset offset button. Okay. Maybe before continuing, I'll quickly show how to change the default units. So there's a bottom left button into the main menu. And we go into units. And then there is the input units, which you can see here are degrees for the grades. Change that to %. Okay. So that would be how to build a simple drain profile along a center line, and you want to offset it down 600 mil using the project offset feature. This next example is very relative, I think, in the infield design for drainage. Okay, we have two known RL levels. So the RL is known at both ends, or there's a fixture concrete area. Okay. So we might be doing a drain from culvert to culvert. So there's concrete, the RL level is fixed. We don't know the slope, but we know the start and end with a physical location or a peg. Again, going to create a new job site. Okay, so here's our job site, empty again. So I think a really fast way to do this efficiently, especially if there's a lot of curves in your drain or you are traveling a long distance, selecting the points could slow you down. So instead of storing the points directly on this screen, we can go straight into models, add a line, and in this page, we can press the add button down here on the bottom left to directly store points. Okay, so now we are on the bottom of the culvert for the start, point 1. Click on add. Again, we don't want any offsets. On point. So now we have this green point 1. So we're going to continue on storing our points along the center line. If you have multiple and it's not just a A-B line. Of course, it can be less points or more points. Okay. So this is a culvert to culvert. Okay, on a property with the fixed heights. So one thing to do, which I didn't do, again, was at the first point, hold your finger down on the first point you stored, which is point 1, and select the I button. This here, the Z value is your RL. So note this down, 125.289. Okay, that's our RL for the first point. Okay. And then, okay, now we're going to store our last point here. Now again, hold your finger on the screen for our last point, pressing the I button to get the RL, 122.658. So the reason we're documenting the two RL levels is we're going to calculate the height difference between the two. Okay, so the height difference between point 1 and the final point. We come into the slope feature here. And to dial in the perfect slope to go from point 1 to the final point, it's rise over run times 100. So we calculate that elevation difference from point 1 to point 2, which turns out to be 2.63 meters. Okay, height difference. The total distance of our line is 144.7. So some quick math, you can do it on your calculator, or there might be some online tools. Okay, but essentially the height difference divided by the total distance times by 100 will give you your slope. In our example, it's 1.82% slope. Minus. So this will give us a line from culvert to culvert perfectly in line, matching the heights. Okay, so now we're going to again build our profile to this. Advanced profile, again, the two slopes, duplicated. Ratios. The same profile, but of course, any ratio or slope percent for your batters. Very good. So again, that's the preferred option when you have a curved drain or anything, or fixed points either end, like concrete or culvert, anything like that. That would be the recommended way to get the slope to match your design. Okay, I think one of the last examples, or
I think we show how to add profiles to an existing line work.
Yep.
Yeah.
So we'll jump on to adding profiles to existing. So this is all infield design, building our own designs, our own lines and attaching profiles. But of course, it's possible to do so with imported models. Okay. So in this example, we have a simple road profile. Okay. As you can see, simple road profile. Oh, sorry. Change the slide. Here we go. So we have our simple road profile, and they've asked us to complete the footpath for this, but they did not provide a surface or anything to go with the request. So what we can do in this scenario is build our advanced profile. Again, models, add advanced profile, footpath, one slope. Okay, in the example, 2.5 meters wide. .49% slope. Okay. Now we can hold our finger on the screen to select which line. Polyline footpath, that's the one. Next page. So as you can see here, that again, the swap cross section is very important. And we know the footpath is off the road, like shown. And that's how you can simply add your own designs to existing imported designs, like a footpath. Okay. All right, I will hand it back to Jörg.
Yeah, thank you, Sam. The only thing left to do is, of course, to go back to the surface measurement dashboard, and then you can measure to the existing imported designs, yeah, or to this footpath that you just created yourself together with us. One last thing before we have 5 minutes or however long we need for questions. Whatever we create on our system, we can also export. So if you click on the project, you can simply export the project. And since we believe strongly in open data formats, or we export our XML files, those can be loaded into any other Xsite system, or as a matter of fact, also into our surveying rover. So if you're going back later, you created a profile on the excavator, but you want to control yourself on your rover, that's something you can absolutely do. Very good. Then we still got 5 minutes left, or a little bit more, of course, up to you in this case, yeah, to the audience. So please feel free to use the chat function or this Q&A function right next to us, or of course send us an email either right now or after the meeting to ask any questions that you got. So I'll just pull up the chat to see, or maybe Daniel, you could take a look at the chat if there's any questions at the moment.
I haven't got anything on the chat, but I saw one email come through asking, with advanced profile, can I do that with a 2D Xsite Pro or only with 3D?
Yes. Yeah, that would only work with a 3D system, because you need to know your position in the profile. But of course, with a 2D Xsite system, you can always upgrade. So it's only a few items required: a GPS receivers, the 2 mushrooms, and a software license. And then you get most of the parts already on your machine, and you can just add these components and create advanced profiles. What's already always possible are the previously shown 2D workflows to bench to known heights or to use a laser as a height reference.
Perfect, thank you. And that's the only message that's come through for now. So we'll give it a couple more minutes, and then I think we will we'll close it off. And of course, we'll share this we'll share this video recording. So of course, you can always view it later and go back to any of the infield designs that Sam and Jörg went through to study in more detail.
And of course, if you have any questions after the webinar, this is our channel contact information from the front office, but feel free to reach out to support either by email or through our 1-800 number to discuss any questions that you might have after the webinar.
All right, then I don't think there's anything else coming through. So from my side, thanks again for everybody taking the time out of their day to join this webinar. And as Jörg said, feel free to reach out if we can help you further, and we'll go forward from there. Jörg, any words from you to close it off?
No, also from our side, thank you for attending today. And yes, you can find a webinar. I think you should get an email about it with a video to watch, but in any case, it will be on our YouTube channel together with all the other webinars and demonstration we have for you. Thank you.
Thank you. Thanks everyone for joining. Cheers.